Hi guys, my name is Adi Rozenberg. Thank you for joining in. I am the CTO and co-founder of AlvaLinks, and today I'm going to provide a presentation on a very exciting thing, which is called IP delivery intelligence. So the topic of the presentation is monitoring live video delivery in the era of cloud and the internet. Why intelligence is so important for live streaming. So, the broadcast industry is running forward with rapid adaptation of the digital transformation to all IP workflows. I'm going to run forward. The industry is moving away from dedicated fibers and MPLS to an internet and cloud for holding live video feeds and production. New reliable delivery protocols like RIST, SRT, NDI, WebRTC allow users to venture out to the new frontiers and spread their wings. Cloud production and remote editing based on JPEG XS, ST2110 is still challenging, but doable. The delivery network is becoming a more problem-prone than before. The old monitoring and root cause analysis solutions are inadequate to take this challenge head-on in this era. What it goes for is more and more responsibilities fall on the broadcast teams to figure out and master the new techniques and the problems that are happening. So you might ask yourself, why reliable delivery is not enough? So I mentioned SRT, RIST, NDI, Quick, WebRTC are very reactive to what is happening. Packet get lost, we are reacting to that and trying to retransmit. We take care of packet loss, we take care of jitter, reordering. We try to shield against network-related problems as they happen. This is great, and everybody should use some sort of a reliable delivery protocol in their workflow. But how do you identify network-related problems and prevent them? We need to get to the root cause of the problems to make sure that we tune our delivery solution and use the right network solution to our intended purpose. IP networks should be treated like a big ocean with currents and many users at the same time that might affect our day-by-day business. Why do we need delivery intelligence? So let's take an example. Look at the weather forecast. Well, think about 20 years ago, we didn't know if this is going to be shining or raining, nothing. Today, we have satellites, we do forecasting, and now you can definitely know on an hourly basis what is going to be the temperature, humidity, and whether you have sunshine or not. So it is not enough to look at the sky and to see whether they are blue. We need to see the trends, what is coming in, to look for the future and what is happening somewhere else in order to understand the weather. And this is exactly what the weather forecast teams do. Today, we use intelligence for many applications. We use that for business intelligence, to identify trends and possible customers. We use seismographs to predict earthquakes. We use ocean buoys to detect sea currents, weather, and tsunami events. Our mobile browser and TV is constantly being monitored to predict our trends, to buy things, and so on. Any aspect of our life is monitored one way or the other. Why shouldn't the internet or the network be different? So what is missing today with what we're doing now? So with broadcast solutions, we have multi-viewers. We have companies that focus on multi-viewer to show you the real video. We have ETR 290 compliance solutions, and we have alarm monitors. You can find a lot of companies in this hall doing exactly that. They all focus on the constant content compression, transfer, packaging, and delivery after the fact, not while it is happening and why is the root cause of problems. IT solutions like Thousand Eyes, Zabbix, SolarWinds, network performance monitors, or the Datadog, give you that information, but they focus on the long-term network availability, application users at slow sampling rate, which is not adequate for video applications. They can't tell you the right jitter. They can guesstimate a jitter every few seconds. Reliable delivery solutions that I mentioned before, they focus on the error and jitter recovery, but have very narrow viewpoint on a stream-by-stream basis and not as a system as a whole of something that's happening. So a problem on one stream that manifests a problem on another stream, you won't see that. And that is a problematic on a day-by-day operation. So how will video intelligence will help you? We will need to focus on the network issues as they impact the service delivery. We need to have more in-depth information on the network impairments that is key for successful, consistent video delivery. We need to have more data points, fast alarms, fast trend indications, fast root cause analysis, and it has to be protocol agnostic. We don't want to have a monitor per protocol or per application. We need to look into the end-to-end delivery regardless of the protocol. System view of multiple flows and stream in the system that interact and cause co-interference. We need to bridge the gap between broadcast and IT teams for quick fault isolation and data collaboration. And of course, testing the performance of any point with reference test stream for precise fault detection. So where intelligence is needed. Every time you have a video-oriented link that you need to use, you need to understand how it will perform for transmission. You need to have it when you do continuous stream delivery. You need to do video path analysis over any type of network domain, whether it's cellular, landline, satellite IP, whatever. You need to fine-tune your delivery protocol for the network conditions. And you have to remember, not all protocols are adaptive, that they can really tune to the network problems. So let's talk about link evaluation. Video-oriented link evaluation, oh, a second, this is a repeat, sorry. So what do we need to do with the link evaluation? We need to do path discovery. We need to discover what makes a path, how many routes, and what constitute a route. We need to understand how many packet loss are in each route. We need to discover the service provider that provides us the path. We need to understand the path RTT, latency, and jitters, and how many hops. We need to do a step-by-step testing of the link for streaming applications. We need to test the packet loss for every step. We need to evaluate the jitter impact on every step, because every bitrate can contribute to a different aspect of problems, and you need to master that ahead of time. So then you need to understand how RTT and latency is impacted, and also how MTU is impacted. And link evaluation is key for every successful live transmission and awareness. So I'm going to jump forward just to show you, I'm about to be cautious about my time. So I'm going to jump forward. So stream delivery performance intelligence, let's look about that. We need to monitor, as I'm repeating myself, but packet loss, jitter variation as they happen, route changes, and I will show you an example about how route changes impact the quality. Burst events, latency changes, all of those impact your video delivery, whether it is compressed, lightly compressed, or non-compressed at all. We need to collect video stream statistics. IP flow detection. What is IP flow detection? Is you need to detect all the IP flows that might hit your destination and impact your service. Those may be non-video streams, and you need to generate multiple alarms and events to make the team know what is going on. so that we can have we can correlate impact of all the flows and elements in one link. Now let's talk about continuous path exploration and statistics. We need to have path analysis. What does that mean? We need to continue to do path discovery and its effect on the video delivery. Now, people are foolish to think that once I decide to stream from one point to another, there's only one path. Those paths change on every minute. We have BGP routers, we have changes in the network, so it's like a living being. Those change. Every change causes problems. It might speed up your delivery, it might slow down your delivery. It can move you through a network which has more packet loss, more jitter, more implication, more users. You need to be aware of that, and you might decide that for your next streaming, you will not use that path or the service provider. So this information is very critical for you to know. You need to do that continuously while you are streaming, otherwise you may get impairments. And as I said, cloud and internet paths change without any notice for a few seconds. You need to have a rich UI with correlated time-based charts for events zoom in and out to understand what is the impact of the changes. And the bottom line is focus on what matters for the video delivery. So you might ask yourself, why should I care? Well, today monitoring tools are inadequate to give you insight on the video delivery issue. A multi-viewer will tell you whether this video is received or not, but what is the network problem. So it's just important to know what is the problem. Time is of the essence. You need to detect problems as they happen, before they happen, and become a serious issue. Information collaboration within the organization and with your partners or service providers is key. And I'm also talking about the IT teams. It's not only broadcast doing its own thing. Today you have to have broadcast, integrators, service providers, and the IT working together to provide a continuous and successful service, and we need to hook them up. We have to speak the same language, which is the language of IP, so that at the end we can identify any link, route, stream problem at no speed. We can't wait for equipment, service provider, or manufacturer to support us. It takes time, usually days, for them to pick up the phone and call you back. You can't be on the mercy of them to provide you answers. You need to be on top of things as they happen. And this, basically, a quick cause analysis is critical. So let's jump to a diagram. And here I am showing you a diagram how intelligence should work. In this example, we have one sender and one receiver going through over two networks. While the stream is delivered, for some reason, there is a balancer that split the stream into two. So now, instead of one path, so we need to see the impact of both paths, and we need to measure them both so that we know what is going on. We need to make that data be available on a shared database so that we can process that, use an AI to identify trends, and visualize that on a web server so that at the end we have a user that sees what is going on. So I'm going to show you 4 examples, and let's see the problems that might happen. So I'm starting with a simple thing, continuous path testing to detect network problems. So we have one sender. He thinks he's sending to one receiver over using one path, and apparently he has a split. So we need to test that somehow continuously and gather intelligence, sending packets constantly as like a video stream, a reference test stream, over both paths to reach the receiver so that now we can have the information. we need constantly to monitor the link. And what do we monitor? We monitor the performance of packet loss, latency, jitter, TT out, and bitrate variation on every link. We need to detect burst losses on outgoing flows so that we will know that losses received were generated at the source and not from the network. So this is important to have the information from the sender. And we need to do the same thing on the receiver. So now we can correlate and understand the problems are generated not by the sender, but actually by the network, and how those problems manifest themselves. Co-interference. This is something something that is very overlooked by many. Co-interference is when you have multiple streams and one stream misbehaves and impacts the other streams. Just like with car traffic, you are riding, chilling in your lane, and suddenly a trucker decides to pull into your lane, and you have to halt, or there's some kind of a crash. It impacts you somehow. So let's see that. What do we need to do? We need to detect those transient events, because the truck will not stay at your lane all the time. It will come, it will move, it will slide over. But we need to be on top of those events to understand that those are transient and they may impact us, and we need to be ready for them. So just like before, we have our regular sender and receiver that we had before, and we are chilling out, we are monitoring that, we are okay. But suddenly, the sender decides to send another stream, maybe a file transfer or something. It doesn't have to be video, it doesn't have to be continuous, to another receiver using the same network. And suddenly it impacts this link. So there's interference on this thing, but not on this. So, but we are monitoring this one. How would we know about this one? So while monitoring, here we can see suddenly sender A and sender B. We can see that there's somebody doing something on the link. And then it gone, and the problem went away. Maybe yes or maybe not. So let's see that as an example from a real capture. We have here a web UI that shows error rate, number of hops, jitter, and latency. And let's see things that we can understand from this capture. Error caused by route changes. You can see the direct correlation of events. Yeah.
You can use your mouse pointer.
Where? This?
Does that give you anything?
Nope.
Okay, never mind.
My hand is better. So error rate caused by co-interference. You can see a great picture here, and we will see another one. This is a file transfer that happened during the streaming. That, look at the impact. Suddenly the packet rate went from almost 0 to 25 and beyond packet loss. And the jitter impact jumped by about 200 milliseconds, because somebody else was using the path for a short time, and that impacted me. I need to be ready for that. And of course, you can see the latency impacts. So let's see some more pictures. I told you about route changes, so let's see here. We have 2 points. We have a transmission. Those are from the same source, the same destination, back and forth. So I want you to see 2 things that are very important here. Number one is number of hops. 17 on that direction. The return is only 15. So it's not the same. It's not the same points. It's not the same exact routing, and you can see the complexity. And the complexity on the top is because we are streaming to a cloud, and the cloud decided to do its magic and do changes as we are streaming. But on the reverse path, it's much more tamed. Also, you can see flows going through the link. Here you can see tens of megabits and spikes happening, and this one is much more tamed because it's a smaller type of traffic. And you can see the occasional data change rates. And these are caused by file transfers that basically go to the HTTP server. The spike is, oh, thank you. Oh,
Hold it down, hold it back a little bit. Yeah.
you can see the spike jumping from 10 megabits to 20 megabits. 10 megabits increase of flow. You can see new flows are generated here while we're doing file transfer. So that causes problems to our stream. Now, without this information, you can't tell anybody anything. You don't have anything. You don't have any evidence to show up to say, hey guys, you are messing up with my service. Let's talk about seamless switching, 7020.22-7. Exactly the same thing, but this is much more hard thing to establish because we have two streams that are doing seamless switching. We need to monitor them much more carefully. So we are doing the same stuff, exactly the same performance that we did before. We are monitoring the source as things happen and how we do perceive them as they hit us. So we can correlate and adjust the streams to have a perfect 7022.22.7 seamless switching for high bit rates, low latency, and the correlation is done using the intelligence continuously as it's being used. Rogue flows in a network. So what is a rogue flow? Is somebody using the same network as us while we are using that. Once again, we are monitoring both ends. And basically, any link and route or interface has multiple RX and TX flows coming in. Those are not in your control most of the time. So you need to be aware of them. You need to you need to monitor them somehow and see whether they affect your video. And then if you see that they do, try to avoid them. So let's see an example of a rogue flow, if you don't believe me. So this is similar to what we had before. We have the file transfers that you recall that I showed you before. And you recall that this was very tamed. Hey guys, from 0 to 150. Somebody decided to send 150 megabits for, it's like 10 seconds over my link. What do I do then? That can overflow my network, that can create jitter, packet loss, whatever. I need to know that. I need to know that so I can tell my IT people, my service provider, guys, you are messing up with the SLA. You are causing me problems. This is not on my equipment. This is on you. 150 megabits of crazy data for 10 seconds. Okay, I'm done. Any questions?